In recent months, growing attention has been directed toward an interstellar object known as 3I Atlas. This body is now approaching Mars, and while its presence is a significant astronomical event, it has also raised questions in both the scientific community and the public sphere. Unlike routine comets or asteroids that originate within our solar system, 3I Atlas is only the third confirmed object to enter from beyond our star system, following the earlier discoveries of 1OI in 2017 and 2I/Borisov in 2019. Each of those earlier cases sparked its own debates, and Atlas is continuing that pattern with unusual characteristics that do not fully align with expectations for a natural comet. The discovery of interstellar objects is still a rare occurrence. Most small bodies that we detect are gravitationally bound to the sun, tracing elliptical orbits that repeat over time. Interstellar bodies are different because they are traveling fast enough that they are not held permanently by the sun's gravity. Their orbits are hyperbolic, which means they pass through once and do not return. For this reason, every such object we observe provides a unique one-time opportunity to collect data before it disappears into deep space. With 3I Atlas, scientists are preparing to use every instrument available, from orbiters around Mars to telescopes on Earth, to learn as much as possible during this short window. When astronomers first calculated the orbit of 3I Atlas, the trajectory immediately stood out. The object is following a path that brings it unusually close to Mars compared to previous interstellar bodies, and it is moving along a plane that is much flatter and more aligned with the orbits of the planets than most interstellar visitors. Typically, interstellar comets arrive from random angles, which makes sense for objects that have traveled from distant star systems. The fact that Atlas is gliding along a course only a few degrees away from the orbital plane of the planets has raised eyebrows in the community. Some researchers suggest this could simply be coincidence. Others point out that even if the orbit is unusual, it still remains within the realm of natural possibility. What makes this case more complex is that the object has displayed behaviors that differ from the comets we are most familiar with. Comets are essentially mixtures of ice, rock, and dust. As they approach the sun, heat causes the ice to vaporize, releasing gas and particles that form the coma. The visible cloud around the nucleus and the tail, which is usually pushed away from the sun by solar radiation and the solar wind. With 3I Atlas, observations suggest that its coma brightened earlier than expected before it crossed the so-called frost line, where solar heating typically begins to cause major outgassing. Brightening earlier than predicted is not unheard of in comet studies, but in the context of an interstellar object it becomes noteworthy. Some teams monitoring Atlas have also noticed that its coma and tail do not behave in entirely standard ways. Under some conditions, the tail appears angled differently, as though being influenced by forces that do not match normal models of solar pressure. These details have led to ongoing debates among astronomers. Instruments like the Hubble Space Telescope and the James Webb Space Telescope are being used to track the object in multiple wavelengths. The James Webb is especially suited for infrared observations, which can detect specific molecules and compounds being released. Preliminary reports from groups analyzing its data have mentioned the presence of organics and silicates in relatively pristine condition. For scientists, this is exciting because it offers a glimpse into the chemical composition of material formed outside the solar system. Since interstellar comets carry matter from other stellar environments, they can tell us about how planets and smaller bodies form elsewhere in the galaxy. At the same time, some of the signals being picked up do not fit neatly into established categories. For example, spectrometers aboard the European Space Agency's Mars Express and the Trace Gas Orbiter have been directed to monitor Atlas as it approaches the red planet. These instruments are capable of detecting gases such as carbon dioxide and other volatiles. Early reports suggest that emissions from Atlas may be irregular, sometimes appearing and disappearing in cycles rather than steadily. This pattern has been described by some as episodic, almost rhythmic. While such behavior is unusual, scientists caution against drawing premature conclusions. Comets are notoriously difficult to predict, and they often surprise researchers with irregular bursts of activity. Another puzzling element concerns the size and activity of the nucleus. Hubble imagery has provided estimates that do not completely match the amount of dust and gas being released. In simpler terms, the core seems too small to account for the activity observed unless there are hidden processes beneath its surface. Some possible explanations include internal pockets of heat, chemical imbalances that accelerate sublimation, or compounds that have not been previously cataloged in comets. None of these ideas are confirmed, but they show the range of hypotheses currently being discussed. A notable aspect of the conversation around 3I Atlas is the limited communication from official agencies. NASA and other institutions have released technical updates confirming the trajectory and monitoring efforts, but they have not offered extensive public briefings or interpretations. Some commentators view this as a standard cautious approach. Agencies prefer to wait for solid data before making public claims. Others, particularly in online forums and independent research circles, interpret the silence differently, suggesting that the object's behavior is more remarkable than officials are willing to acknowledge. It is important to note that in science, silence is not evidence of secrecy. It often reflects the need for careful verification before results are shared. Nevertheless, the lack of detailed commentary has added to the sense of mystery for the public. Historical comparisons are relevant here. When Oumuamua was discovered, it quickly became the subject of speculation because its shape, acceleration, and lack of visible coma did not resemble ordinary comets. Some scientists proposed that it might be a fragment of a disrupted planetesimal, while others entertained more speculative possibilities, including artificial origins. With 2I/Borisov, on the other hand, observations showed it behaving much more like a traditional comet with a well-formed coma and tail. 3I Atlas seems to fall somewhere in between, with characteristics of a comet but also several anomalies. This middle ground fuels both curiosity and debate. As Atlas approaches perihelion, the point of closest approach to the Sun, the uncertainty grows. Perihelion is scheduled for October 31st, when the object will be subjected to extreme heating. For comets, this is often a decisive moment. Some disintegrate entirely, breaking apart under the stress, as happened with Comet Ison in 2013. Others survive and continue along their orbits, albeit altered by the intense passage. Predicting which outcome will occur is difficult. Models can provide probabilities, but every comet is unique. In the case of Atlas, observers are divided. Some expect fragmentation, others predict a spectacular flare-up in brightness, while a few suggest it may endure without major change. During this critical period, Earth-based observations will be limited because Atlas will pass behind the Sun from our vantage point. That means ground-based telescopes will lose sight of it, and even some space-based instruments will be overwhelmed by solar glare. The Solar and Heliospheric Observatory (SOHO) and NASA's Stereo mission may be able to capture some data, as they specialize in observing near-solar phenomena, but the coverage will not be comprehensive. This window of invisibility adds to the uncertainty. The time when Atlas is most active may also be the time when it is least visible to us. Mars-based orbiters will still have line of sight, but the relay of data from them is slower and subject to limitations. The broader scientific importance of 3I Atlas lies in the fact that every interstellar object expands our sample size. With only 2 confirmed examples before it, each new observation is precious. Scientists are using this opportunity to refine models of how interstellar comets form, what kinds of materials they carry, and how they evolve as they interact with the Sun's environment. Even anomalies that appear confusing at first can provide clues about physical processes we do not yet fully understand. Whether Atlas fragments survives or behaves in entirely unexpected ways, the information gathered will contribute to our understanding of planetary science and interstellar chemistry. It is also worth recognizing the human element in these events. Whenever data does not match expectations, speculation naturally arises. Some of this speculation remains grounded in science, focusing on outgassing rates, orbital mechanics, or spectroscopy. Other commentary goes further, raising questions about intent or artificiality. While such ideas capture imagination, the majority of researchers remain cautious. They stress that unusual does not necessarily mean unnatural, and that the best approach is to wait for evidence. The universe is filled with processes that can appear strange until they are better understood. Each new object reminds us that our models are only approximations, and nature often finds ways to surprise us. As the date of perihelion approaches, monitoring efforts are intensifying. Teams from different countries are coordinating observations, and instruments across multiple platforms are being tasked to follow Atlas as closely as possible. The expectation is that in the months ahead, data will be compiled into papers and analyses that gradually piece together a clearer picture. Until then, the combination of limited visibility, unusual behavior, and scientific caution ensures that the mystery of 3I Atlas will remain a subject of discussion. In summary, 3I Atlas is the third known interstellar object to pass through our solar system. Its trajectory near Mars and its early unusual activity make it an important case study.
Scientists are using telescopes and orbiters to study its composition and behavior, noting both familiar and unexpected features. While speculation has grown around its anomalies and the relative quietness of official agencies, the most likely explanations remain within the framework of natural processes. The real significance of Atlas lies not in speculation but in the chance to expand our knowledge of material that formed around other stars. Regardless of what happens during its closest approach to the Sun, this object will add valuable data to one of the youngest and fastest growing fields of astronomy, the study of the stellar visitors.